right, 6.1, the identities. This is part number 2. So, I don't know, I'll do a few examples. Like I said, we're breaking this up in a couple days, a couple more days. So, any ideas? Anybody want to do left or the right? Chase, since you weren't here yesterday for some of this, I'll let you pick. Any problem can be done by either side. Left side? Quiet, please. Now, here's a fancy way. If you really are insistent, you put let y equal theta. That's a very mathematical way of saying, now I can put all thetas. And it's a valid move.
You don't have to write that, though.
Yeah, you should. You should document everything. You're letting y equal theta. Because in calculus, we have 2 such documentations in a problem so that we know later on what the heck our answer means. So this is just getting you used to documenting things like we do in calculus. All right? In Calc 2, you have a couple more things you document within the same problem. So now, any ideas what to do next? All right, apparently, College Road does not feel the importance of following the class today. So, why did you think I was talking about you? There are 4 people in your row. No, I am not. I talked to Michelle earlier, didn't I, Michelle? No, not about you. Sine 1 minus cosine. Ooh! Next is what? Yeah, conjugate. Now, that's not always Jessica. Sometimes it's Savannah and Katie and Kaylee. Anytime Savannah looks the other way, I call on her. All right. Yeah, every time I see you talking to Katie. So it's, wait a minute. I forgot where I was going. Parentheses. Plus. So you can multiply out the conjugate. And I don't think I'm going to multiply out the numerator. Do you think so? I don't know if I'm getting anywhere with this. I'll try. 1 plus cosine. If not, we can always erase and start over. No, it just means 1 less attempt to try, or 1 less way to try it.
There's like a billion different ways.
Yeah, 1 minus cosine squared is equal to what? There. Remember, we were trying to get plus cotangent of things. So that's what we were trying to get.
And we got it.
Yeah, somebody just said you can divide off on the signs. Write this as 2 terms. Plus cosine of sine. And we have a, remember, short actually until it matches. Okay? Fantastic. She likes these problems, so do I. All right. Ready? Ready to move on?
Oh, man.
Hopefully they get a little bit more challenging. Did we get through 25 or 15?
25. Oh, my.
Well, let's do number 20.
Oh, my God.
In honor of the Packers winning the Super Bowl, let's do 20.
What does Packers have to do with?
Because I'm going to call him Sam Gilly.
Okay.
I'm going to put my opening statement here first, though. Let 4x equals theta.
Why didn't they just put theta?
Well, there's a very good reason why they put 4x there, and I'm going to tell Kylie and Katie in just a minute, that pretty soon you're going to be working with multiple angles, and they're just exposing the fact that you can have 4 times the angle there. But 4 times the number is still a number. So I'm just going to reference it all by theta, since you don't know any double angle formulas yet, you don't know any sum and difference formulas yet, you don't know any half angle formulas yet, but they're exposing you to the fact that that's going to be happening later on in this chapter. So Zach's looking around. I think we're ready to start. Sam, any ideas?
Combine the denominator.
Combine the denominator? Okay.
Yep, let's not do that.
Well, let me change. If I'm going to change one, I'm going to change the other one. Now, I realize that this is a, not a very high-level move, but it's still effective if you change the sines and cosines. You don't have to do that, but if I don't have anything else to do, that's what I do. Then what did you say, combine the fractions?
Yeah.
Okay. So I'm going to combine them while Sam's picking that up. I'm multiplying top and bottom by the cosine of theta. I don't like denominators over denominators. Never have, never will. Do you have to do it like that? I think you've seen from your work that no, you don't. But, like I said, I'm doing it like this. Cosine theta, sine theta,
Oh, this one's easy.
plus. So everybody says that after the initial thought. It's like, any ideas what to do now? Remember, you're trying to get 1 over sine, so you can go get to cosecant theta. What? Yeah, factor out sine. Now, some of you will rise up into very good identity people. That's fantastic. Others need to understand this is the opening section of the chapter. We're going to have a lot more fun. So keep after it. Keep working on your game. And yeah, once you get that one hint or one thing of what to do, you should feel pretty good about yourself. Questions on that one? The directions change later on after 50, by the way. I don't think we're going to get all the way through 50. We're going to get close.
Okay.
Right, and then later on this week we'll get past 50. Okay?
Wait, we're gonna be doing 6.1 all week.
No, we're going to the computer lab Thursday.
Say tomorrow.
Yeah. Tomorrow's homeroom. I can get a couple examples and assessment in. Does anybody remember what to do with this one from the one before? Left or right, and what do you do? Oh, I'll wait. Everybody's writing it down, including Chase? Everyone on the left side? Nice. Factor out secant squared? Yeah. Secant squared minus 1 does equal tangent squared. What's secant squared equal? 1 over cosine? Yeah. Or 1 plus tangent squared.
Oh, that was weird.
Easy? I don't think these are easy. I think it's like when you watch Food Network. If you ever try to replicate some of those things they do on there, it's pretty hard. They make it look easy. I try to be.
What? I mean,
Yeah.
Average person.
Sure they do. They just see things a little bit different than I do. That's why it looks easy to them. Plus, I think they have like a lot of help behind the camera.
Nuh-uh.
Yeah, I think they do. I think so. They have probably this big, massive machine shed in my kitchen. It does. And so every once in a while I can pull it off. I can pull off the look-like.
Mm-hmm.
Yeah, I can.
Does it taste the same?
I can't taste it from TV. I don't have taste division. All right, ready? All right. I think we did that one, didn't we? Oh, we got to do this one. Well, that other one's like an appetizer. This is like something the main course right here.
Talking about two. Even though I just say I'm selfish. Wait.
Look at this.
There's like 50 variables in there.
50 variables. I count 3. All right. Well, okay, we'll let t equal theta. How's that? So we got A cosine t minus B sine t squared plus A sine.
Let t equal theta.
Oh yeah, theta. Okay, okay. I don't think Stephanie's gonna watch this. She might. Sine theta plus B cosine theta squared. All right, anybody want to do right side?
No.
Oh, come on. It won't be that bad.
Yes, I will. Can we do the left, please?
All right, left side. What should we do? Obviously, multiply it out. FOILing is when you distribute twice. I think we can just use a shortcut for this, can't we? We know it's going to be A squared cosine squared theta minus 2AB cosine theta sine theta plus B squared sine squared theta. Now, let me make a little note here to self. Cosine squared of theta is the same thing as cosine theta all squared. They mean the same thing. One's obviously a shorthand way of writing it. The other one's a graphing calculator way of writing it. But if you want to carry your work through with this, cosine times cosine is cosine theta squared like that, that's fine. They mean the same thing. So, in that respect, what do I get when I multiply out the second one? A squared sine squared theta plus 2AB sine theta cosine theta plus B squared cosine squared theta. I think that is awesome. Sure. Zach sees something. What do you see, Zach? Right, so those are opposites, so they're gone. Ooh. Yeah, you can factor an A squared out of these two. And, yeah, by the same argument, factor out a B squared. Yep, that's a Pythagorean identity for one. So you have A squared plus B squared equals A squared plus B squared. Again, not too difficult. I don't have one today. All right, I'll see if I can find one real fast. All right, she took the book back. Who is that over there making a big ruckus? Savannah.
Oh my gosh, this one is.
All right. Huh? Not for much longer. All right. We are going to do,
What?
I don't know, whatever came up, finger aerobics ripple in honor of Stephanie.
Are we recording this?
We are.
Nice.
All right. All right. Stand up. All right, stand up. Make an X with your arms out in front of you. Move your palms to face you with your fingers up in the air. How do I scroll down, Sam? Oh, there it is. Okay. So, you'll be triggering 2 fingers at a time. Triggering is when you pull the finger you like, you would pull the trigger of a spray bottle. Here's the order you'll be doing this in. Ready? Right index, left pinky. Right index, left pinky. Right middle and left ring. Right ring and left middle. Right ring. Nice job, left middle. right pinky and left index.
I can't do.
Now, same sequence in reverse order. Ready? Right pinky, left index.
It's not because like these are.
Right ring, left middle. And then right middle, left ring. And then right index and left pinky. All right, you're supposed to, I see, you're supposed to have the first one, second one, third one, fourth one. Not counting your thumbs, going left to right, right to left. All right, ready? Now, try to do this again. Now you know the moves. Now do it on your own, quickly. Ready?
Wait, okay. Wait, I gotta start again.
Oh, that's nice. Nice job, Stephanie. Keep it up. All right, have a seat.
Alex never partakes in our memories.
I know. He's an Ortega.
So lame-o.
Wow. Saving down.
All right, quiet please. This is when, on these problems, this is when you are going to start having some fun.
Are we? I thought we were already having fun. Yeah.
Listen very carefully. There are two different angles
You kidding me?
that you have to keep track of. U's and V's. Thank you for your opinion. Now back to what I was going to tell you. So now you can't do the old lets. If you want to get fancy, if you want to see the future, you would let U equal A and you let V equal B. That will be the future of your note card eventually. You will see that next week. So the problem will look like tangent A minus tangent B all over 1 plus tangent A. You don't have to do this. I'm telling you, you're going to see a lot of A's and B's next week. The reason they didn't use A's and B's now is, well,
Lame.
no, they wanted to wait. Cotangent B, cotangent A.
Waiting for Kristen?
No, they're waiting for the double angle identities. Cotangent A, cotangent B plus 1. These are, I know which, these are actual identities you're going to put in your card later, but we won't talk about that until then. So right now we just have to solve, which to me it looks like maybe 2 steps. I'm saying that cotangent is reciprocal of tangent, correct? So I'm going to change this to 1 over tangent of B, aren't I? I'm going to change this cotangent to 1 over tangent of A, aren't I?
Sorry.
Tangent, I'm sorry, I'm going to keep this up. And I still remember the faces when I first did this of like, that is stupid, I'm never going to do it. Well, you don't have to. But it's problems like these that we found, if you just sludge them out to begin with, they're pretty easy. So what am I going to multiply this by? Yeah, I'm going to multiply it by tangent A, tangent B. If you see that, that's great. But there are many instances where I teach at Parkland, they have never seen multiplying fractions or expressions by ones that look like this. Tangent A, tangent B, tangent A, tangent B. They just don't, they aren't exposed to this kind of mathematics. This kind of mathematics is very useful later on.
What about the one?
What about the 1?
Tangent A, tangent B.
What is 1 times tangent A, tangent B?
Tangent A, tangent B.
And that's in my solution. Okay? So if I multiply this whole first term, I'll have tangent A, and I'll have tangent B, and then I'll have
Oh.
1 plus tangent A, tangent B. Now, there's a fancy way of signing off on these, but we'll do that another time. I don't want to do it today.
But why didn't you distribute the ends and the one?
I did. I multiplied it by that. multiply by that. There's only 2 terms down there.
Oh.
Okay? There's not 3 terms, there's 2. All right. That's pretty good. My goal is to get to 50 today, and this will be the last one. This one is still an identity, but you have to use your natural log laws along with your trigonometric identities, just like we did our perfect square. The natural logs, once you've done a couple of them, aren't very bad at all, as Alex can attest. Alex is way past, aren't you, Alex? You're way past this? This one? Oh. Alex, what do you remember about natural log? Actually, what do you know about secant? Good. 1 over cosine. Obviously, I chose the left side because earlier I said you have to be able, I like to change the sines and cosines. We don't usually use fractions with natural logs. What do we use? Yeah, negative exponents. Natural log, cosine theta, -1. And our log law allows us to do what? Put the -1 out front. Negative natural log, cosine theta. Fun. It's the same as the other ones. It's a puzzle set forth in front of you
Yes, it's easier.
that you solve.
Makes it more fun.
So I'm going to try to get through 49. Tomorrow, 17. Tomorrow is up in the air. If I'm here,
It's not a movie.
yeah, if I'm here, we will have regular class. If not,
Here, where will you be?
I will be possibly, wait a minute,